Okay, good afternoon, everyone. We had a long gap of 1 week, maybe 10 days between the previous lecture and this lecture. So we had started off with definition of control system. Then we talked about some few examples of control systems. We briefly discussed about open loop and closed loop control system. We'll continue our discussion further and try to have few more examples of open loop and closed loop systems. Just to have a quick recap, we had one of the classifications of control systems as open loop system and closed loop systems. In an open loop system, output is not fed back to take corrective action. Most of these systems are timer based. We had taken the examples of toaster, डोमेस्टिक टोस्टर आपण ज्यातनं टोस्ट बनवतो रॉ ब्रेड टाकतो and then we put the timer on, we put the heater on, and thereafter after that certain time period the toast baked and roasted toast pops up of that toaster. And then we took the case of traffic control system as well. In most of the traffic control systems, all the 4 roads or 4 lanes are opened sequentially. A fixed time period is given, in certain cases 1 minute, in certain cases half a minute, in certain cases 2 minutes, and after that time is elapsed, and then the signal on the next road is put on and it continues sequentially. So there also we don't take any feedback of the traffic control. In the first case of toaster also, we don't take the feedback whether the toast quality, desired toast quality is obtained or not. We just presume if I put the toaster on for 1 minute, 2 minutes, 2.5 minutes, whatever it is, I take it for granted that the baked roasted toast would be ready. But there is no guarantee as such. Even in washing machines, we set the washing parameters on the washing machine. Let it be the temperature of water, let it be flow rate of water, let it be concentration of detergent, let it be amount of stirring or the torque applied on the clothes for washing. So we set those parameters and we start the cycle, we start the wash cycle. And the wash cycle is maybe for 15 minutes, 30 minutes, 45 minutes, 1 hour, depending on different settings available to us. And after half an hour or whatever is the set time, the wash cycle is completed. And there also it is called as open loop system because we don't take the feedback of the washed cloth quality as such. We don't take a feedback whether the clothes are clean or not. We presume, or if the calibration of the washing machine is perfect for cleaning, for cleanliness, then we are likely to get the desired output quality. So there is a likelihood, there is a sort of probability, there is a sort of dependence in case of open loop system. But if the calibration, if rigorous experimentation is done, and if a chart is provided as far as toaster is concerned, if you have a raw bread going for 2 minutes of setting, if it is a fresh bread, so going for maybe 2.5 minutes of roasting, then you can get the desired toast quality. But it all depends on the type of calibration, the type of experimentation we do, rigorous experimentation, then provide the data to the user. Even in case of traffic control system, if for a given chalk or a given 4 lane, if we carry out rigorous experimentation on morning hours, on which road, if you have got 4 roads, let us say road 1, road 2, road 3, road 4, on which of the roads in the morning hours the traffic is more, in which of the roads in the morning hours the traffic is less. Accordingly, we can set appropriate timings on those roads. If road number 1 has got more traffic density in the morning, let us say, if you take the case of Satrasta, many around 9 o'clock, 9:30, people coming from Vijapur Road will be going in to their offices in the morning hours. So on that road, the traffic would be more. So there I require more timing given for flow of traffic on that road. Whereas from station side, maybe the traffic would be less. So for that road number 2, I might give lesser timing. So if that calibration is correct, I will have smooth flow of traffic. And same is the case with washing machines. If I, for cotton clothes, with moderately dirty clothes, what should be the temperature of water, what should be the detergent concentration, what should be the amount of twisting of the cloth, what should be the amount of stirring. So based, if you carry out rigorous experimentation, this open loop system also might give me good results, so to say. Whereas in closed loop system, I need not worry about dependence because that closed loop system will take care till the desired output is obtained, it will not stop. So it will constantly take the feedback of the output, like a furnace temperature control system. There will be a sensor which will be sensing the temperature, and I have the desired temperature of 1000 degrees Celsius. That is the set temperature. The desired output is 1000 degrees Celsius. The closed loop system or the feedback control system ensures that within the furnace 1000 degrees Celsius is maintained. How it does that? By providing one sensor, and that sensor will be sensing the temperature within the furnace on regular basis, and it will be giving a feedback to my controller, to my comparator first of all. If the present temperature is 900 degrees Celsius, corresponding to that, the transducer which is sensing that temperature will give the feedback of corresponding to 900 degrees Celsius. My set value is 1000 degrees Celsius. So whatever is the deficit of 100 degrees Celsius, the controller will give signal to the heating devices. Let it be steam, let it be maybe fuel that is burned, let it be electrical heater that is providing heat inside the furnace. It will be kept on till the temperature rises from 900 degrees Celsius to 950, 970, 980, 1000 degrees Celsius. Or in a sense, till the error between the feedback value and the set value becomes zero. Similarly, CNC control system machine tool also, it controls the turning parameters, milling parameters, shaping parameters, whatever is the machine. Till those parameters are achieved, the cycle would continue. So it ensures that the desired output is obtained. So this is what we discussed briefly. Just to take a quick example of open loop system and closed loop system. This is of course taken from Bolton's book, and it corresponds to room heating system. Room heating system is very common in Western colder countries, maybe European countries or Americas or Russia, wherein in most of the times in a year you have got colder environments, so they require room heating system on regular basis. Let it be by the room is heated by burning wood or maybe by using electrical heaters. Unlike our Asian countries, Asian countries never or very rarely they require room heating system. Maybe probably the Kashmir region, Himachal Pradesh region, Assam, and these Himalayan regions wherein the temperatures are sometimes sub-zero temperatures. There, the room heating systems are required. Otherwise, in the peninsular India, we don't require, mostly we don't require the room heating system, but we require air conditioning system because of the tropical environment. But this example corresponds to room heating system. Just if you just observe, the input is decision to switch on or off the room heater. The controller, which is a person, his hand is actuated, it puts on the switch, and the electrical fire that is generated within the room, and the output is temperature change within the room. Now this is the open loop system. We don't take the feedback whether the room is heated or not, or desired temperature within the room is obtained or not. So it is a open loop system. The same open loop system can be converted into a closed loop system or a feedback control system by providing a measuring device. See, rest of the things are same. Controller, switch, electric fire is there. Only thing is that the sensor, the measuring device is provided, and feedback is taken of the actual temperature within the room, and it is compared with the set value. If the set value is 30 degrees Celsius and present temperature is 20 degrees Celsius, the deficit of 10 degrees Celsius is reduced by putting the heater on for further more time till the error becomes zero, till the temperature within the room becomes 30 degrees Celsius. So quickly we'll have the definition, just be attentive. We have open loop system, a system in which output is dependent on input but controlling action or the input is totally independent of the output of the system. So we don't track the output in the open loop system. It is called as open loop system. So reference input, controller, most of the cases timer, the process that is controlled and the controlled output. Okay, so the feedback is not taken in open loop control system. So it's an open loop. So there is no loop as such. So it's an open loop. So advantages, it is simple in construction, less costly, of course, because no complicated circuitry will be there. Simple in construction, very much convenient when output is difficult to measure. Easy from maintenance point of view, these are the advantages. Not troubled with the problems of stability. Stability in the sense, see, let us take the case of a classroom. If I'm taking a class, and if I am taking the feedback of the students constantly, what happens is the concentrated or the focused student gets disturbed. Why the teacher is troubling? Whether you're following me, if I'm taking feedback constantly, that disturbs the stability of the students as well as the class, the entire class. So the closed loop control system tends to make the system unstable, so to say. Whereas in open loop system, in a way is stable, but from teaching learning process, the teaching learning process has to be a closed loop control system. Even if I have given you example of open loop system, most of the cases, unfortunately, the same thing happens. Most of the teaching that happens in the class is open loop system. We are least bothered whether the knowledge transfer has taken place or not, the output is achieved or not. The teacher comes to the class, writes on the board, and delivers his lecture for 1 hour, 45 minutes, whatever it is, and he goes back. Students also, some are attentive, some are not attentive, some digest the concept, some don't digest the concept, some do some other work. So the open loop system is least bothered what is happening to the system. In this particular teaching learning case, unfortunately, it is open loop system in most of the cases. It has to be closed loop system. The teacher has to take the feedback whether the student has understood the concept or not, and accordingly he has to do the modifications in lecture delivery. So every teacher, including me, I have to take care of that, whether the students are understanding the concepts or not. So though कसं आहे, क्लास चालू आहे, शांत आहे, बाहेरून जाणाऱ्या माणसाला वाटतं पॅसेज मधून जाणार, काय शांत क्लास आहे, एक समजूत होते की छान लेक्चर चाललेलं आहे, छान टीचिंग लर्निंग प्रोसेस चालू आहे. पण देयर आर टू पॉसिबिलिटीज. सांगितलेलं सगळं समजतंय किंवा सांगितलं काहीच समजत नाही. टीचर आपल्या भाषणामध्ये दंग आहे, टीचर आपल्या लेक्चरमध्ये दंग आहे, मुलं आपल्या कामात दंग आहेत. सिस्टम इज स्टेबल. But there is no guarantee that knowledge transfer has taken place. Okay, just for fun sake, I took that example. Most of the teachers are looking for feedback control system also. We all teachers are dedicated teachers. Don't worry about that. We take the feedback and then we proceed and we see to it that knowledge transfer takes place effectively in the classroom. So the next point is the open loop systems are not troubled with the problems of stability. Okay. Then simple to design and hence economical also. So the toasters, why these are cheaper? Because there is no complicated feedback system that is involved. So traffic control system is also cheaper. It can always be converted into a feedback control system. Even a toaster can be converted into a feedback control system by using some imaging devices. If I use some camera which will capture the image of the toast color, म्हणजे असा ब्राउनिश टिनचा झाला, क्रिस्पी झाला की चांगला टोस्ट झाला. I can have a camera which will generate an image, and I can have a light sensor, a reflected light sensor, and I can convert that toaster open loop system into a closed loop system. But the cost will increase. So that might not be economical for a simple purpose of preparing a small toast. So toast काय तसा शेगडीवर डायरेक्टली टाकला तरी टोस्ट होऊ शकतो, बेक होऊ शकतो. So for simple applications we go in for open loop systems where the control parameter is not that critical. Okay, so it is simple in design and it is economical. Let us see the disadvantages. Inaccurate and unreliable, because accuracy of such systems are totally dependent on the accurate calibration of the controller. Now calibration म्हणजे काय? जसं मी सांगितलं, रिगरस एक्सपेरिमेंटेशन करायला पाहिजे. टोस्टर एवढा वेळ लावला की एवढा चांगला टोस्ट मिळालाच पाहिजे. कधी मी अश्युरन्स विथ श्युरिटी सांगू शकेल जर मी खूप वेगवेगळ्या टाईपच्या ब्रेडवर एक्सपेरिमेंटेशन केलं, शिळा ब्रेड, ताजा ब्रेड, वेगवेगळ्या ब्रँडचा ब्रेड, वेगवेगळ्या वेळासाठी, व्हॉट हॅपन्स इज शिळा ब्रेड आणि ताजा ब्रेड मध्ये बेसिकली फरक काय? शिळा ब्रेड मधला वॉटर कंटेंट, मॉइश्चर कंटेंट कमी झालेला असतो. फ्रेश ब्रेड मध्ये मॉइश्चर कंटेंट असतो, त्यामुळे तो लुसलुशीत असा फ्रेश दिसतो आणि वाटतो आणि असतोय. So based on those facts, if I do rigorous experimentation and त्याप्रमाणे जर टाइम सेटिंग प्रोव्हाइड केलं, त्यालाच आपण कॅलिब्रेशन म्हणतो. तसंच ट्रॅफिक कंट्रोलच्या बाबतीत पण मी प्रत्येक रोडच्या ट्रॅफिकचा स्टडी करून जर टायमर सेट केले, ज्या रोडवर ट्रॅफिक जास्त आहे तिथं स्टडी करून सकाळी, दुपारी, संध्याकाळी, रात्री, इफ आय कॅरी आउट स्टडीज अँड कम आउट विथ द डेटा, त्या वेळेमध्ये मग टायमिंग थोडेसे अल्टर होतील. जर डफरीन चौक घेतला आपण, डफरीन चौकामध्ये इकडून एम्प्लॉयमेंट चौकाकडून येणारे ट्रॅफिक, स्टेशन कडून येणारे ट्रॅफिक, हायवेकडून येणारे ट्रॅफिक, किंवा हायवेकडे जाणारे ट्रॅफिक, किंवा स्टँड करून येणारे ट्रॅफिक. इफ यू ऑब्झर्व मोस्ट ऑफ द टाइम्स इकडून एम्प्लॉयमेंट चौकाकडून येणारी ट्रॅफिक आणि स्टँड कडे जाणारे ट्रॅफिक, हेच रोड जरासे जास्त क्राउडेड असतात. मग तिथं व्हॉट कॅन बी डन, डू कॅलिब्रेशन. म्हणजे काय, मी स्टडी करेन सकाळी, दुपारी, संध्याकाळी, त्या वेळेला ह्या दोन रस्त्यांवर टायमिंगचं ड्युरेशन वाढवेल, सो दॅट कसं होतं, नाहीतर स्टेशन कडून येणाऱ्या रस्त्याकडे काहीच ट्रॅफिक नाही, पण तो बिकॉज इट इज ओपन लूप सिस्टम आणि टायमर सेट आहे, त्यामुळं एकही जरी व्हेकल नसलं तरी यू टू वेट टिल दॅट एंटायर सायकल इज कम्प्लीट. So if the calibration is good, open loop systems also work nicely. Another disadvantage is these give inaccurate results if there are variations in the external environment. Okay. There are environmental changes because there is no feedback. Open loop system cannot change the system parameters on their own. Such systems cannot sense environmental changes. This is the major drawback of open loop control system. Third disadvantage, they cannot sense internal disturbances in the system after the controller stage. बरोबर, सिस्टम मध्ये काहीतरी बिघाड झाला, ते पण काही सेन्स करू शकत नाही. त्याचं काम काय, टायमर सेट केला, टायमरनी कंट्रोल सिग्नल दिला, इट विल जस्ट गो ऑन डिलिव्हरी. इट इज लिस्ट बॉदर्ड. जसं मी वर्गातलं एक्झाम्पल घेतलं, मी जस्ट बडबडत गेलो तासभर, मुलांना कळतं किंवा न कळतं, आय डोंट बॉदर. सो इंटरनल डिस्टर्बन्सचा पण मला काय परिणाम होत नाही. असे टीचर्स असतात की काय कोण गप्पा मारते, बडबडते आणि काय तरी माझं लेक्चर डिलिव्हरी चालू आहे. काही सेन्सिटिव्ह टीचर्स असतात, ते फीडबॅक आहे, गप बस, चुप बस. बट सम टीचर्स दे डोंट बॉदर. चालू आहे तुमच्या, तुम्ही गप्पा मारा, काय करायचं काय खडू नका, व्हॉट एव्हर यू वॉन्ट टू डू, आय विल कम्प्लीट माय लेक्चर अँड गो. सो these open loop systems cannot sense internal disturbances as well. To maintain quality and accuracy, recalibration of the control is necessary from time to time. So these are the major disadvantages of open loop control system. So a toaster system, just to recap, we have taken, if I want to show it in the block diagram format, desired time, I use a relay or a controller, the power input is given, heating process of the bread, and actual toast. So this is what is the representation of automatic toaster control system or toaster system. So here also a traffic controller, traffic light controller, you have desired time, relay of the controller which is the switching on each of the roads, power is supplied. So the indicator lights may be green, yellow, red lights, and the actual traffic control happens or does not happen sometimes. Let us go to the closed loop system. A system in which the controlling action or input is somehow dependent on the output or changes in the output is called as closed loop system. As I said, it takes the feedback constantly and it takes the corrective action all the time. Feedback is a property of the system by which it permits the output to be compared with the reference input. Feedback is a property of the system by which it permits the output to be compared with the reference input to generate error signal based on which appropriate control action can be decided. Ha major advantage of feedback. Actual system parameters sense केले जाते, set parameter बरोबर compare केले जाते, आणि deficit असेल, surplus असेल, त्याप्रमाणे कंट्रोलरला corrective action घ्यायला भाग पाडलं जातं. And in the process, the output parameter is constantly monitored and controlled. So if you see the block diagram, such questions are asked, draw the block diagram of a closed loop control system, the block diagram representation of a closed loop control system. So you have the command input, reference transducer, which sets the control signal, so to say. आता आपण एक example बघूया. Let us say the furnace control example. That will be the process to be controlled. Your furnace will be the process or the system to be controlled. So the temperature mara maintain करायचं. Controller will control the temperature. The control output is, let us say, temperature. Thermocouple is, let us say, my feedback, my sensor transducer. What the thermocouple will do? It will sense the temperature and convert it into equivalent voltage. So that equivalent voltage is my system signal now. म्हणजे ह्या लूप मध्ये कुठलं सिग्नल ऍक्ट होत आहे, इवन दो इट इज अ टेम्परेचर कंट्रोल सिस्टम, कंट्रोल सायकल मध्ये कुठलं सिग्नल वर्क होत आहे, मे बी इलेक्ट्रिकल सिग्नल, वोल्टेज सिग्नल और करंट सिग्नल, दॅट इज माय वर्किंग सिग्नल. मग करस्पॉन्डिंग टू लेट अस से 1000 वोल्ट 1000 डिग्री सेल्सियस इज इक्वल टू 10 वोल्ट्स. म्हणजे 100 डिग्री सेल्सियस म्हणजे 1 वोल्ट. म्हणजे सध्या टेम्परेचर समजा 900 डिग्री सेल्सियस आहे, तर त्याचा थर्मोकपल इलेक्ट्रिकल सिग्नल मध्ये कन्वर्जन काय करेल, 900 डिग्री सेल्सियस विल बी कन्वर्टेड टू 9 वोल्ट. 9 वोल्ट सिग्नल इथं कंपॅरेटरला आलं, एरर डिटेक्टरला आलं. कंपॅरेटर काय काम करणार, माझं 1000 डिग्री सेल्सियस इज माय सेट व्हॅल्यू, 1000 डिग्री सेल्सियस इज माय कमांड इनपुट, दॅट इज माय टेम्परेचर सिग्नल, म्हणून त्याला कमांड सिग्नल म्हणायचं. मग रेफरन्स ट्रान्सड्यूसर काय करणार, तर 1000 डिग्री सेल्सियसला इट विल कन्वर्ट इनटू इक्विव्हॅलंट व्होल्टेज सिग्नल. मे बी अ पोटेन्शियोमीटर आहे, एक नॉब आहे. पोटेन्शियोमीटर काय करतो, कॅलिब्रेटेड डायल आहे, त्याच्यावर मी टेम्परेचर मार्क करतो. पण ऍक्च्युअली काय करतो मी, रेझिस्टन्स वायर, ओमिक रेझिस्टन्स मी व्हेरी करतो. म्हणून डायलवर जरी मला टेम्परेचर 1000 डिग्री सेल्सियस दिसत असेल, तर ऍक्च्युअली मी बॅक साइडला, बॅक एंडला काय करतो, 10 वोल्ट सेट करतो. The constant of calibration is 100 degree Celsius is equal to 1 volt. So मग reference transducer काय करतो, maybe potentiometric transducer, it will convert the command signal of 1000 degree Celsius into 10 volt signal, and that 10 volt signal will be my reference input. So 10 volt is my set value and actual temperature is 900, so 9 volt. So 10 minus 9 is 1 volt is my error signal. That error signal plus 1 volt is my error signal. It will be amplified, it will be modified, it will be conditioned and given to the controller, and it will actuate the heater. मग काय heater on झाल्यानंतर काय होईल, now this is called as manipulated variable. Controller will receive the error signal and convert it into manipulated variable, maybe voltage or current signal. ठीक आहे. आणि मग heaterचं इनपुट वाढवलं आणि what will happen, फर्नेस मधलं टेम्परेचर वाढायला लागलं. टिल व्हॉट टाइम, 900, 910 झालं, 920 झालं, 950 झालं, 950, 960, 980, 1000 झालं की लगेच हा सेन्सर काय करतो, कॉन्स्टंटली कन्वर्ट करतो. थर्मोकपल विल कन्वर्ट द 1000 डिग्री सेल्सियस इनटू 10 वोल्ट. That will come here at the comparator. 10 volt is my reference input, 10 volt is my feedback signal, B is the feedback signal. 10 minus 10, 0, so error becomes 0. The controller will put the heater on. Ka? Well, desired temperature is achieved. So the controller, in typically a closed loop control system or feedback control system, controls the system parameter effectively. Now we'll discuss it briefly once again. Reference input R. Now R is a function of time. What this RT corresponds to? It's a function of time. Error is also a function of time. Manipulated variable is a function of time. Control signal is also, controlled output is also function of time. Even feedback is function of time. म्हणून त्याला bracket मध्ये T. So time dependent control system असं म्हणतो. I think friends, we'll stop for today.